This video will guide you through majority of the rest of the pages on the handout. Feel free to work with someone else and it'll make it a lot easier so you guys can kind of talk about the problem. It's better just to work with somebody else. So this problem is called Music Anyone? So we have this table. It shows the percent of recorded music sales that came from music stores for the years 1998 through 2004. Notice that the music sales are going down every year, and that has to do with online downloading, so people are not buying CDs as much as they used to. Every year they're buying a lot less. So that's the first thing I want you to notice. So number one, we want to represent the data as ordered pairs. Remember, ordered pairs are points in the parentheses with a comma in between. And we want to put the percent of the total sales that came from music stores as a function of time. So time comes first, music sales will come second. So X will be time, music sales will be second. And we're going to let X represent the number of years since 98. So we're not going to put 1998 on our point. So that's going to be our first question. This is not how we're going to write it. Do we write the coordinate as 1998, comma 50.8? The answer is no, because X represents the number of years after 1998. So 1998 would be considered the first year or the second year, or how will it be? So 1998 will represent as 0. 1991 will represent year 1. That's a year since 98. 2000 will be represented by the year 2, and so on. So let's go ahead and write that on our actual table just so we can have those numbers in front of us. So 1998 will represent year 0, year 1, year 2, year 3, year 4, and so on. All right, so go ahead and take care of those ordered pairs. 0, comma 50.8, 44 goes 1, comma 44.5, and so on. So you're going to write these down. So 0, comma 50.8, and go ahead and do the rest of them. Pause this video as you work on this, and then you can hit play once you're ready to come back to it. All right, now that you have the numbers, you should have the following in front of you. All right, let's go ahead and do number 2, which is graph these points. So these points are just showing up on the right again, just so you can have them in front of you in the video. But go ahead and start graphing this point at 0, go up 50.8. Again, approximate as best you can. Let's label our axis like we should always label our axis. Again, where I got these from is from the previous slide from the table. The first one, X independent. Second one, Y dependent. So year or time and percent of sales. And we want to make sure we're clear in the years after 1998. So let's go ahead and graph it. 50.8 is right there. At 1, we're going to go up about 44.5. I would say pause this, graph them, and then just double check your work. So here are the rest of the points. And we see a negative trend or a negative correlation. Points are slowly and steadily going down in a linear fashion. So let's go ahead and go to number 3. We're going to describe any patterns you see in the data. I wrote some key vocabulary you can use in your explanation. So here are like 3 sentence starters. The graph looks, and explain what the graph looks like. As the years pass, explain what's going on. The graph has a blank, and go on from there. So again, fill something out in this section. Based on what you see on the graph, use the vocabulary of the story. What's happening since 1988? What's happening to the number of music sales? All right, now that you have number 3 done, go ahead and log on to desmos.com. Do the linear regression. So you're going to go back to this table. You're going to type in these numbers here on the T table on desmos.com. So you're going to put these on that table as 0, 50.8, and so on with all 1, 2, 3, 4, 5, 6, 7 of these. Make sure you log them. Then you're going to type in the y equals, not equals. You want the squiggly, y1, and then mx1 plus b. So we're going to type this into the Desmos, and it will give you your linear regression line. So go ahead and take care of that. Let's go back to the slide we're on. So again, on Desmos, make sure you take care of that. Write out what your equation is. So when you're done, you should be writing down y equals blank, right? What is your equation? Don't forget the x on it. Happens a lot. So again, right now my linear regression equation is y equals blank x plus blank. So go ahead and pause this until you're done with that. All right, now that we have our linear regression equation, let's go ahead and interpret the equation of the line in terms of the problem situation. So the linear regression equation tells you that what's happening on a yearly basis. You're going to be using those two numbers from your slope and from your y-intercept. The number of sales is dropping this much every year. Something to that effect is what you're going to be writing in this sentence. All right, let's move on to the next piece. If there is a linear association, meaning that the points go down or the points go up, they're not just scattered all over the place, between the independent and dependent variables of a data set, you can use linear regression to make predictions. So predictions are only really good when it is a linear regression. So for example, if my points look like this, and they're kind of all over the place, me making a line on it and trying to make some kind of prediction off of this data, let's say something like this, will be pretty useless. But if my points are, like in our example, nicely going down, I can actually put a line on there and it will give me a pretty good prediction of what's happening in the future. So let's go ahead and look at that. So when we make predictions, this is called interpolation. So again, the basic definition of interpolation is just making a prediction with the data we have when it is in a linear order, whether positive or negative or constant. So me making a prediction based off that line is called interpolation. All right, so now we should be on number 6. So we're going to use our equation to predict, keyword, the percent of total music sales that came from the music stores in the year 2000. So this is our equation you should have gotten from Desmos if you did it. Now we're going to take this equation and we're going to predict the music sales in the year 2000. So going back to our table, the year 2000 was considered, remember this was year 0. Whoops, what's going on here? Let's try it again. 1998 was the year 0. 1999 was the year 1. 2000 would be considered year 2. So we're going to plug in the number 2 into our equation to make a prediction. So let's go ahead and plug in that 2. We're going to multiply and combine it with the 48.89. That gives us 42.95. So the prediction is that in the year 2000, music sales will be at 42.95. So I'm going to write that out. The percent of total sales for music stores in 2000 should be about 43%. I'm just rounding that to the nearest percent. Now we're going to do number 7, which says compare the prediction, which is number 6, what we just did, 43%, to the actual percent in 2000. Now the actual percent is back up there on the table. If we look at the actual percent in 2000, it was 42.4. So the actual percent is 42.4. So the predicted value is fairly close to the actual value. Our line of best fit is pretty on point. So it was pretty close. Now we're going to do the same thing. Now it's your turn to do this on your own. So we're going to use the equation again like we did on number 6. But this time you're going to do the year 2003. So again, remember this is 0, 1, 2, 3, 4. And we don't want that. And how do I make 4? Sorry about that, you guys. Having issues here. So number 5. So year 2003 would be 5. So when you do this now, you're going to be plugging in the number 5 and seeing what the percent is. And you should be giving me a very similar sentence frame as we had on number 7 to answer number 9. The actual percent is blank. Look at the table. So the predicted value is blank. Look at your answer for number 8. Go ahead and pause this and take care of this. Then hit play when you're ready to move on to number 10. All right, so the next question is, do you think a prediction made using interpolation, remember, using our equation, will always be close to the actual value? If you say yes, tell me why you think it's always going to be close. If you say no, tell me why it's not always going to be close, maybe sometimes, and explain why you're saying this. So here's just something to get you started. I think interpolation will, you were probably right, always be close to the actual value, or I think interpolation will sometimes be close to the actual value, and then finish it off with because on both of these options. Go ahead and pause this and bring it back when you're done. All right, now you're done with number 10, flip to the next page, and we should be working on number 11 now. So let's look at, what about making predictions when it's not in the data set? And we call this extrapolation. So the definition's in that dotted line, box, I'm sorry. To make predictions for values of x that are outside of the data set, it is called extrapolation. So again, when your prediction is not in the data set, what that means is, for example, in this table, we're going from 1998 all the way to 2004. That's where my data is located. So the predictions I made earlier were for the year 2000 and 2003, I believe. So those were both within the data set. Extrapolation would be to make predictions outside the data set. So after the year 2004 or before the year 1998, like 2010 or 1980. So that's what we're going to be doing next. We're going to be making some extrapolation predictions. So number 11 says use the equation. So again, we're going to use our equation again to predict the percent of total music sales that would come from music stores in 2010 outside our data. So here's our equation. So 2010, what is 2010 in terms of our years? Remember, this is 0, 1, 2, 3, 4, 5, 6. That's 2004. So 2005 would be 7 and 6. Well, 6 would be number 8. Well, 7 would be number 9. 08 would be 10, 09 would be 11, and 2010 would be number 12. Let me write a line here just to separate it. So we're going to be substituting X for 12 because in 2010 that's 10 years after 19, I'm sorry. X is 12 because 12 years after 98, that's when 2010 will be. So let's go ahead and plug in X equal to 12, multiply 2.97 negative times 12, and then combine it with 48.89. So the prediction is 13.25, and it's in percents. So here's my sentence of what I'm going to go with the situation. So using the equation, I would predict that about 13%, rounding that 13.25, of the total music sales would come from music stores in the year 2010. Now it's your turn, so you're going to be going ahead and doing it for 2020. Again, outside the data, extrapolation, and the year 1900, which is way outside the data, way before. So go ahead and figure out what numbers you would be plugging in. And go ahead and pause this and come back to do number 12. So now that you're done with number 11, parts B and C, let's go ahead and answer 12. Are these predictions reasonable based on the problem situation? Meaning, do these predictions for the year 2020 and 1900 make sense? Yes or no? And explain. So you would say these predictions are reasonable because, or you would say these predictions are not reasonable because, or you can say one is reasonable and one isn't, and explain why. Alright, so now that we're done with this, we're going to move on to the next page, but I will be putting it on another video because this one's already running over.